Okay, let's get right into it. We hear this stuff constantly, right? Artificial intelligence is going to completely change medicine. And the promise, it's incredible. We're talking about algorithms with superhuman abilities, spotting diseases way earlier and more accurately than we ever thought possible. But, how much of that is just hype and what's actually happening in your doctor's office today?
I mean, that's the big one, isn't it? We see these headlines pop up all the time. Study after study comes out showing some new AI model beating a whole panel of expert radiologists at their own game. It really feels like the future is already here.
But that's the puzzle. If these tools are so incredibly powerful, why aren't they everywhere? Why hasn't your trip to the doctor changed one bit? Well, it turns out there's this massive gap between the research lab and the real-world clinic, and that's exactly what we're going to break down. First, though, let's just stop and appreciate how staggering the potential of AI really is. Seriously, the research coming out of labs is genuinely mind-blowing. It gives us this amazing glimpse of what is theoretically possible. And look at this list. The range of what AI can do in the lab is just wow. We're talking about models that can spot diabetic eye disease from a simple scan, find cancerous moles on the skin, pick out tiny malignant nodules on a chest x-ray. It can even predict Alzheimer's from brain scans. But wait, there's more. It can detect funky heart rhythms on an ECG, predict your heart attack risk just from a photo of your retina, help choose the best embryos for IVF, and even predict the risk of dying in the hospital based on health records. The list just goes on and on. It's a really impressive body of work. So with all that amazing potential, we hit a wall. We come to the central problem. There's this huge gap, a chasm really, between these incredible lab results and what's actually being used to, help patients in the real world. And this gets right to the heart of it. Researchers even have a name for it, the AI chasm. And what it means is that just because an algorithm gets a 99% accuracy score on a test, that doesn't automatically mean it's useful or even safe in a real hospital. A high score doesn't always mean better health for patients. A huge reason for this chasm is how these AIs are even tested in the first place. See, most of these big studies are retrospective. That just means they use these perfect, clean, historical data sets. But the real world is messy. So when these same AIs meet new patients, different equipment, messy data, their performance, more often than not, just tanks. So the big question is, why? To really get the AI chasm, we have to pull back the curtain and look at all these hidden scientific traps and data problems that these models keep falling into. Let's start with just a number. 6%. What on earth could that mean? It means that in a huge review of AI medical imaging studies, a shocking 94% of them never even tried to test their model on data from a different hospital. That's called external validation, and it's the most basic way to find out if your AI can actually function out in the wild or if it only works in the cozy little lab where it was built. Okay, so one of the biggest reasons these AIs fail to generalize is because of these sneaky things called confounders. This is where the AI doesn't actually learn what you want it to. Instead, it cheats. It learns a shortcut, some hidden clue in the data that's connected to the disease but doesn't actually cause it. There's a really famous example of this. Researchers trained an AI to tell the difference between a wolf and a husky, and it worked perfectly until they figured out what was really going on. The AI hadn't learned anything about wolf anatomy. It just learned that pictures of wolves almost always had snow in the background. It learned the completely wrong thing. And believe it or not, this exact same problem happens all the time in medicine. One AI learned that a skin mole was cancerous because doctors tend to put a ruler in the photo next to suspicious moles. Another AI, supposed to find pneumonia, really just learned to recognize the specific portable X-ray machine used on the sickest patients. They've learned to link hip fractures with scans marked urgent and even thought surgical skin markings were signs of melanoma. They're learning shortcuts, not medicine. But, okay, let's say you fix all the data problems. Even then, you slam into a whole new set of challenges that have nothing to do with code and everything to do with systems and, well, people. Which brings us to a massive hurdle: trust. You see, a lot of the most powerful AI models are what we call black boxes. They spit out an answer, but they can't for the life of them tell you how they got there. And for a doctor to trust an AI with a patient's life, they need to understand its reasoning. That's the whole point of a new field called explainable AI, or XAI. The thing is, right now, we're kind of stuck with this trade-off. The models that are the most accurate, these deep learning networks, are usually the hardest to explain. They're the black boxes. And the models that are super easy to understand, we call them glass boxes, well, they tend to be a little less powerful. And this tension, this tug of war between performance and transparency, is a huge roadblock for doctors.
So, beyond trust, there's an even more dangerous problem. The data we use to train these AIs, it's a reflection of our world, with all of its existing inequalities. So, what do you think happens when an algorithm learns from that data?
It can learn and even amplify our worst biases. If an AI is trained mostly on data from one group of people, it can fail and fail dangerously on everybody else. For example, we've seen skin cancer models trained mostly on light skin perform much worse on skin of color, a flaw that could cause a delayed or misdiagnosis. Other models that predict risk in hospitals have been shown to be less accurate for patients from different backgrounds. This isn't just a technical glitch. It's a massive safety issue that could make healthcare less fair.
So, with all of these huge challenges, the data problems, the trust issues, the safety concerns, what's the way forward? How do we actually bridge this chasm and get from promise to practice safely?
While the experts have a pretty clear roadmap, first, robust evaluation. We have to stop obsessing over simple accuracy scores and start running real-world clinical trials that measure actual patient outcomes. Second, we have to tackle bias head-on. That means testing models on diverse groups of people before they're ever used and actively looking for any signs of unfairness. And third, we've got to improve interpretability. We have to build models that can explain themselves so doctors can actually understand and trust what they're doing.
At the end of the day, the goal here isn't about replacing doctors. It's about augmenting them. It's about building powerful, reliable tools that act as a co-pilot, helping our human experts reduce errors, work more efficiently, and ultimately lead to better and fairer care for every single one of us. So, maybe we've been asking the wrong question this whole time. The real challenge isn't just, can we make an AI that's intelligent? It's, can we do the hard, careful work of building one that's robust, that's fair, and that's truly worthy of our trust? That is the real challenge and the real promise of AI in medicine.